Good morning friends, welcome back to Panika Tutorials. In the last video, I have discussed what is a dynamic memory allocation, what are the functions you can use such as malloc, calloc, realloc and free functions. All these things I have discussed in detail. I hope you have watched that video. If you did not watch that video or if you don't know those concepts, I request you to go back and watch that video and come back to this video. In this video, I want to discuss in detail about the malloc function, and also I will discuss one C program to make you understand the malloc function in detail. So I request everyone to watch the complete video for better understanding. What is the full form of malloc function? It is memory allocation. Okay, so to allocate the memory dynamically, we will use a function called malloc. What is meant by dynamic memory allocation? The process of allocating the memory at the runtime is called dynamic memory allocation. What are the limitations which are there in the static memory allocation will be eliminated using the dynamic memory allocation concept. So let me discuss the generalized syntax of malloc function. So this is the generalized syntax of an malloc function. This function will take a size as a parameter. Suppose let's take that user has entered the size as some 20. Then 20 bytes of memory will be allocated contiguously and will be written by a void pointer. So malloc is a function, name of the function, and this function will return a void pointer. Let's take that you want to store some 5 integer constants or n integer constants using the malloc function. Then what you have to do is that you have to mention malloc. Let's take that n integer constants you want to store. Then you will specify n, and you don't know whether you are running this program on a 32-bit compiler or 16-bit compiler. For better safety, you write sizeof int. If you are running this program on a 16-bit compiler, then you know that sizeof int will give you the 2 bytes. Okay, let's take that user has entered the n value as some 10 during the runtime. Then 10 into 2, 20 bytes of memory will be allocated. If you are running this program on a 32-bit compiler, you know that one integer variable requires 4 bytes of memory. So 4 comma 10, so it will be 40 bytes of memory will be allocated. And you have to do the typecasting int star, because if the 40 bytes of memory allocated is successfully, means 40 bytes of memory is allocated during the runtime successfully, then the base address of that one you need to store using a pointer. The pointers plays a major role in the dynamic memory allocation. Whatever the memory you have allocated, to access that one or to use that, you have to use the pointers. So as you are storing the integer pointers, you have to store the address of an integer variable using an integer pointer. So you have to declare a pointer p. I hope it is visible for you, or let me write here int star p equal to, you will write this one. Is it clear? So that's why you are doing the typecasting. Whatever the memory, you are making it to an integer pointer because it will return in void pointer. So you are asking to return it as an integer pointer. So that address you will store with the help of an integer pointer. So this is about typecasting and malloc function. Now for better understanding, I will discuss one C program, and I want to tell one important point here also. Let's take that user has allocated 20 bytes of memory to store 5 integer constants. Okay, then you know that you can store 5 integer values. Let's take that the base address of this one is 100, and you are running this program on a 32-bit compiler. You know that one integer variable will occupy 4 bytes. Then the next one will be 104, 108, 112, 116. Why I am saying this 100 to 104 is because one integer variable will occupy 4 bytes. So from 100th byte to 103 byte, the first element will be occupied. From 104 to 107, second element will be stored. From 108 to 111, the third element will be stored. Is it clear? Now, if you does not assign any values to these memory locations, and if you are accessing or if you are displaying to the user, it will give you the default values. That is what about the variables also. So the default value of a malloc function is garbage values. Meaning is that you did not initialize or you did not store any integers in this memory location, and if you are printing the values within this memory location, then it will give you a garbage value. Whereas in the calloc function, it will be default values will be 0 if it is an integers. If it is a characters, it will be null. I hope you have understood this point. Now let me write a C program related to the malloc function for better understanding. Okay. You know that to access these functions such as malloc, calloc, realloc and free, you have to include a header file called stdlib.h. Okay. So let me write the program for your better understanding. Hash include stdlib.h to use those malloc function, and to use the printf and scanf functions, we will write stdio.h. When we will use the string.h, if you want to use any string handling functions, then only we will use the string.h header file. Now I am writing void main. Okay. Then I am declaring the variables I comma n. Okay. First I will ask the user to enter the n value. What is the purpose of that one? I will discuss after the entire program is done. Enter the n value. Okay, backslash n to go for the next line. Scanf percentage d, because n is an integer variable, so I am using the format specifier as percentage d ampersand n I have to give. Then what I need to do is that I want to allocate memory to store n integers. Okay, then what I need to do is that I need to use malloc n into sizeof int. Okay, and then I need to do the typecasting, because malloc basically default it will return a void pointer, so I am doing it a typecasting, and I am declaring an integer pointer and I am assigning to the base address. If the memory is allocated successfully, the base address of this one means the starting address of the block will be assigned to the P. If the memory is not successfully allocated, then null value will be assigned to the pointer P. So you need to check if P is equal to null, then you have to write printf memory is not allocated. Okay. Once the memory is not allocated, how can you store the elements? It is not possible. So you have to exit from the program. So you can use a exit function with some integer as a parameter. Either you can write exit 1 or exit 0. So this is, if let's take that memory is successfully allocated, then you have to ask the user to enter those elements. So you will write for I is equal to 0, I less than n, I plus plus, then I will write printf enter the element. I will write backslash n, then scanf, as the user is entering the integer, the format specifier I have to write it as percentage d. Now I told you that pointers plays a major role in this dynamic memory allocation. The memory allocations will be accessed with the help of pointer. Here it is P. So here you have to write P plus I. What is that one? I will discuss for you. Don't worry. Okay. Once the user has entered all the elements, now I want to display those elements to the user. So printf enter the, the elements are, whatever the elements are there, you want to display them. The elements are \n, okay, for I is equal to 0, I less than n, I plus plus, printf percentage d \n, okay. After printing one value, you want to go to the new line, so that's why I'm using a \n, which is an escape character. Then you want to get the value, that's why you are writing this one. Once it is done, you can write the get ch, or you can close. Or if you want to release the memory which is allocated, then you have to write free function, because already I told you in the last video that whatever the memory you have allocated, you only have to release the memory. Similarly, let's take that files. Whatever the file you have opened, you have to close the file. Similarly, whatever the memory is allocated dynamically, you have to release the memory. So you have to use a function called free, and you have to write the name of the pointer which is pointing to this one. And then you have to write p is equal to null to avoid the dangling pointer problem. Then you write the get ch and close it. So this is the program for making you to understand the malloc function. Now let me discuss this one. You know that each program will start executing from the main function. So here you have declared two variables I comma n. Now let me write here I and n variables are declared. As they were not initialized, these two variables will have the garbage values. And I am asking the user to enter the n value. Let's take that user has entered the n value as 4. Okay. Then here what I am writing, int star p is equal to malloc of n into, so 4 into size of int. Let's take that you are running this program on a 32-bit compiler. Size of int will give the 4 bytes. So 4 into 4, 16 bytes of memory you are asking the user to allocate. Let's take that 4 bytes, means 16 bytes of memory is allocated from the address location 100 to 1115, means 116, means 16 bytes of memory will be allocated from 100 to 1115. Means why I have written 1112, but why I am saying 1115? Because it is an one integer. I am telling the base address or the starting address. One integer will occupy 4 bytes, so it will be from 1112 to 1115. This one also 100 byte to 103 byte. First element will be required. Am I right? Because it is a 4 bytes. Now look at this one. Suppose let's take that due to some issue memory is not allocated. You know that this function will return a null value. If the memory is allocated successfully, then the base address or the starting address, which is 100, will be assigned. If the memory is not allocated, then it will assign a null value. So if p is equal to null, you are writing that memory is not allocated and you are exiting. If the memory is allocated, you are running a for loop. A for loop will have 3 sections. One is the initialization, condition, updation section. Now you are doing the initialization, I is equal to 0. So now the I value is 0. Okay, or let me write here, I is equal to 0, n is equal to 4. Okay, now what will happen? I less than n, 0 less than 4. Yes, the condition is true. If the condition is true, you have to execute these statements which are there in the for loop. So the first statement is enter the element. So that will be displayed as an output. Once the user has entered the n value as 1, means element as 1. Let's take that user has entered the element as 1. Now where I need to store? Usually, if I want to store a variable, I am giving the address. Am I right? In that address location, you have to store the value. Now here I have written scan of percentage d p plus I. What is the p is consists of? P is consists of 100, which is an address. Okay? Are you able to understand? And I value is initially what? 0. So 100 plus 0 will be 100. I agree. But as it is an address, you need to multiply this 0 with the size of the variable. Here size of the variable is int, so it is 4 bytes, which will be 100. So in 100th memory location, you are storing the value 1. Then I plus plus I value will become 1. Okay. Then again the condition you are checking. 1 less than 4. Yes, the condition is true. Then again you are asking the user to enter the element. So this time the value you are entering is, suppose let's take the 10. Then in which address location you want to store? %d, it is an integer. P plus I. What is the P value right now? 100 plus I value is 1. So don't think that it will be 101. 100 plus 1, where 100 is an address. So whenever you are adding with an address, you have to multiply this one with the size of the variable. As the size of the variable is an integer which is 4 bytes, so it will be 104. In 104 location, you have to store this element. Then I value will be incremented to 2. Again the condition is true. Again you are asking the user to enter the element. Now let's take that this time he is entering the element as 100. Then it will be stored in 100 plus 2 into 4, which will be 108. In 108 memory location, the element 100 will be stored. Then I value will become 3. I plus plus, because after this executing of statements it will go to the update section, so I value will become 3. 3 less than 4, again the condition is true. Again you are asking the user to enter the element. Let's take that this time the user has entered 1000. This value you want to store in an address location of P plus I. P is 100, I value is currently 3, so 3 into 4, which will be 12. 12 plus 100, it will be 112. 1112. In 1112 address location, you want to store the element 1000. Okay. Now once it is done, you will go to the I plus plus. Now I value will become 4. Now 4 is less than 4. No, because I value is 4, n value is also 4. 4 is equal to 4. 4 is not less than 4. So this condition is failed. Once this condition is failed, it will come here. Means it will come out from the for loop. Look at what is the statement which is there after the for loop. Print of the elements are. So this will be displayed as an output. The elements are. Now you have another for loop. Initializing from I is equal to 0. Now again the I value will become 0. Okay. I less than n. N value is still 4. I plus plus. Okay. Now look at here. 0 less than 4. Yes, the condition is true. So printf %d, you want to display an integer in which location, because here you have to specify the element, okay, with which value you want, not the address. When you are storing the address, you have, whenever you are storing the element, you have to give the address. In printf, we will give the variable. So as it is a pointer, we are using the dereference operator P plus I. Initially the I value is 0 and P is having the 100, so 100 plus 0 into 4, which will be 100, using the dereference operator. So dereference operator means you go to the 100th memory location. What value is there? 1. That will be displayed as an output. I hope you are understanding. Then I value will become 1. And again the condition is true. Then again, now you are printing 100 plus 1, which is nothing but 100 plus 1 into 4, dereference operator. So you go to the 104 location, whatever the value is there, it will be 10. Next time I value will become 2. Like that it will print all the elements. When the I value will become 4, the condition will be failed. It will come to this free. Now once you have done everything, you have to release the memory. So that's why I have used a function called free, and the name of the pointer I am giving. Whatever the pointer which is allocating this memory or accessing this one or pointing to this memory, you have to give here. And to avoid the dangling pointer problem, I have initialized the P to null, and I have written the getch and close the main function. So this is the C program to create the memory dynamically using the Malloc function, and how to store the elements in the memory, and how to access those elements. All these things I have discussed in detail. I hope you have understood. If you still have any doubts related to this concept or related to this program, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.